Hey, on this final review video, we're going to talk a little bit about just some of the features of Desmos that you might want to be aware of to make your experience simpler and easier on test day, as well as how we can use Desmos to figure out some things about linear equations or lines, specifically how we can find the slope of a line using Desmos. And then we're also just going to basically review a little bit of what slope is, linear equations, y-intercepts, things like that, that Desmos can't necessarily do, but can show you, but also that we should know for the test. So just some settings that this little page shows you that if I put the equation of a line in Desmos, so I'll do that, y equals 3x minus 2. The first thing is if I go to this gear, if I have my equation typed like this and I go to this gear, you'll see there's a little table there and it will create a table of values for me and it'll show me some points that are on that line. And so there's many ways to figure out what the slope of a line is. One of them is just by looking at the number in front of x when we are in y equals mx plus b form. So this is in y equals mx plus b form. And remember that slope is m. So the slope of this line is 3. Another way that we could figure out slope is by counting. Remember that slope is change in y over change in x. So how much do we have to go up and down or up or down, and then how much do we have to go left or right? So if I'm looking at this graph on Desmos and I have these points plotted because I changed it to a table, I can count for my slope. I have to go up 1, 2, 3. And then actually there's another point. If I go to the right one, there's another point. So my slope is up 3 over 1. Up and to the right are positive, and that would simplify to be 3. So we can, if we have the equation in this form, we can choose the number in front of x, and that's our slope. Or we can count how much do you go up or down, and remember up is positive, down is negative, and then how much do you go right or left? Right is positive, left is negative. And if you remember from back at the beginning of the year, I was pretty annoying about saying always start on the left and go to the right. Start on the left and go to the right. So whenever we're counting in the horizontal x direction, if we start on the left and go to the right, we're always going to have a positive number on the bottom. And so the thing that will make a slope negative is counting down. I'm going to go fast here like I have in the other reviews because there's a lot to cover. But if any of this is fuzzy for you or you need another explanation, just please do ask, pause, and raise your hand. What we're trying to show you over here is the settings. So that's that wrench. If I click that, right now, when you look at the boxes, they're each worth half of a unit. And that can get tricky because you might be counting over one and think that it is one whole unit. In fact, that's how I found the slope, even though it worked out okay. So you might want to go and click this big A, and now it's bigger. We can see the numbers better, and each box is worth 1. So my slope is still 3. 1, 2, 3 over 1. So again, you click the gear, click the capital A, and that makes each box worth 1, which is helpful to keep you from making some sort of mistake. This was meant to show you the table, but I did it on the previous page. If you do zoom out, this is a good idea. If you zoom out at any point, or maybe zoom too far in or too far out, like this house will pop up. It won't be there if you're zoomed all the way in to the default view, but sometimes you won't be able to see something, and that's because you're zoomed too far out or too far in. You click the house, zoop, and it makes it nice and easy for you. And you can see the house is gone because you are in the default view. Always remember when you start a new problem to delete all of this stuff, so you can exit all out, or you can click the gear and click delete all. If you forget how to count for slope, if you're a little stressed out on the test and you forget how to count, there is another way. Of course, we got to remember one way. So for this one, we're doing change in y over x. So we went down 2, that's negative 2, right 4, that's positive 4. And you can see down here, we simplify that to negative 1 over 2. Another thing that you can do is find coordinates and create a table in Desmos. So we have coordinates here of, let's see here, I think this one they said is 2, 4, and this one is negative 6, 8. And so we can go make a table in Desmos, and we can type those coordinates in there just like we did in the last review for line of best fit. And it should plot those 2 points. I'm going to hit the house. Oh, there it is. We can actually hit the zoom and find them. And then we can use that formula that we use for line of best fit. Y1 squiggly mx1 plus b. And it's going to show you the slope is negative 0.5. We would just do negative 0.5 in Desmos and click the fraction button, and we get the slope of negative 1 over 2. So lots of different ways to find slope of a line if you are asked. You can use a table. You can count. You can look at the equation if you have it. Remember, in this form, the slope is the number in front of x. So if we were to write this equation, it would be y equals negative 1/2 x, to start at least. So here we have one that is not in y equals mx plus b form. So we can't just look at the equation for the slope. So I would recommend graphing this. 2y minus 5x equals 4. And then we could do some counting to find the slope. And it might be a little difficult, but we're starting there. We're going to count up 1, 2, 3, 4, 5, and then over 1, 2. So we could get a slope of up positive 5 over 2, which is what you see here. That rise is how far do you go up or down in the y. The run is how far left or right in the x. So if you're looking for a slope and you can't see it right away, graph it. So then some questions that we're going to be asked about slope and y-intercept. If you remember the y-intercept, that is the place where it crosses the y-axis. And we're going to see these things that look a little tricky, but really we can just start graphing. So I have this f of x equals x. So I could actually graph that just the way I see it. And then I'm going to go ahead and we are going to look at both of these at the same time. And we're trying to compare this blue line to this line that's on my computer screen. And so we're asked about the slope. How can we compare the slope? So this is g of x. The one I graphed on Desmos is f of x. And so my options here for these slopes are twice, 1/2, 2 less, or 2 more. And so I need to find the slope. Well, the slope of this line is up 1, right 2, 1/2. The slope of this line over here is up 1, right 1. So 1 over 1. So it looks to me like the slope of g of x, this one, is 1/2 the slope of f of x, which is just 1. And then we're looking at the intercepts. Well, the y-intercept of this f of x1 that I graphed is 0. The y-intercept for this one right here for g of x is 2. So it looks like the y-intercept for g of x is 2 more than f of x because it's positive 2 and f of x is 0. This is a similar one. We have the we are saying that if we take this f of x, that's this one, and we shift it up 2. Shifting up means we're going to change our y-intercept, and it's going to be right there, up 2. And then we want to make it 3 times as steep. Well, we have f of x right here, and we have it here, and the slope is 1. So 3 times as steep means we multiply that slope by 3, which means our slope is 3. So we would plot this y-intercept, and then we use our slope 3 to go up 3, right 1, and we have another point, and we could, that's what they're looking for, plot 2 points. So when we shift, we're moving the y-intercept, and when we change the steepness, we're changing the slope. So if I have it multiplied by 3, I just do times 3. If I have a slope half as steep, then I would multiply by 1/2. Similar here, this is one where they're trying to present it to you where we don't see it, but we could always go graph it. We could go graph g of x, and maybe it won't let me do g of x, but I'll just do 6x minus 1, and that's the green line. So remember that f of x has a slope of 1 and a y-intercept of 0. And so shifting, that means we're changing the y-intercept. Our green one has a y-intercept of -1. That means we shifted it down. And so your choices here would be up or down, but we shifted it down because the y-intercept went down from 0 to -1. And then this one's going to ask us, is the new line g of x steeper or less steep? And we're just going to look at how it's slanted. If you picture the blue line and the green line as hills that you would have to walk up, I would think that the green hill was steeper than the blue hill, so we would choose steeper. I wouldn't want to walk up the green hill. And finally, we have to remember that parallel lines, we're talking here about parallel lines, parallel, they have the same slope. So if we know the slope of the original line that we're given, then we could use that slope to find another point that, so we can draw a line through this point and that new point. And so my slope would be down 1, 2, 3, 4, 5, down 5, right 3. So -5 over 3, -5 over 3. And so I can do the same thing. Starting at this point, I can go down 5 and right 3, and I would click that spot, and then I would be able to draw a line through there that would be parallel to the purple line. It's a lot of information in one short amount of time. If you have any questions, please make sure that you ask for help. Please make sure you do these practice problems that are after this. Check your answers, show us your work so that you get credit, and ask for help when you're stuck so that you'll be confident on the day of the test if you approach a problem like this. Take your time and good luck.